talking. All right, good. The students from YouTube, if you can hear me, say yes. All right, all right, let's go ahead and start. This is week 5, episode number 9, and let's go over the Slack stuff first, which is, I think here. And let's see. Yeah, so for your information, the first exam grades are out. So you might see that it's a very beautiful normal distribution with the center about 70 points. Okay, so it's a little bit chaotic, yeah, we all know. But still, right, you see students doing exceptionally well. Um, so yeah, just so that you know, still some of the students, they are definitely very attentive to the announcements, and they try to practice maybe going through the Google form ahead of time. All right, and do know what TA tries to communicate, because this time we try to be a bit more relaxing and not taking points of minor issues. And number 3 here you see, if you follow the suggestions that I posted in exam 1, try to submit at least once after you fill in the basic information. You will finish the CAPTCHA early because the subsequent submission does not require CAPTCHA. Okay, so if you do it at once in the end, oh, okay. Which of these pictures contain a part of the airplane? Oh, wow. Okay, so this is already the last second. No time to think. Okay. So for all these things that we post on the exam, we try to advise for a reason. Okay. Similarly, some of the students tried VPN to the web server, but suddenly VPN not working, and realizing that previously he was doing it at the dorm. He was not really using VPN, so yeah, VPN connection issue. All right. So this is just so that you know. Some students do attend to the announcements, and they do very well. Okay, even though for a very long exam. Yeah, so this is so me adding to Caleb, saying that you might want to, pay attention to the announcement, given this is a very different form. And this is very important, okay, because below the average, We do see quite some students. I know that you guys did well, but you kind of fall below maybe 50 points. Many of them probably because of the new form. Okay, I can see that there is a significant number of students suffer, okay, from this new format. Okay, so as said at the end of the exam, this is a very new format, so chaos is expected. That is why in this course we have 4 exams, because we know that you're going to screw it up the first time. And if we just have midterm and final, oh wow, how are we going to deal with that? Okay, so that's 20 points going to the semester grade. Okay, so good that we anticipated this. Okay, but you see that why are we still doing it this way? Because this form of teaching and learning is growingly important. Okay, so think about once you get into learning this form and doing exams this form. Okay, these Coursera courses and MIT OpenCourseWare courses are no longer that far-fetched. Okay, I think previously you probably tried to attend to the lectures there. It's a little bit hard to follow, isn't it? Yeah, videos is already hard because you are not familiar with. Okay, now when going through the semester that you're seeing videos a lot, that makes it a lot easier. Okay, another reason is this. Okay, yeah, so the point of the college is that you learn to adapt as well, not just to pick up the knowledge, all right? So this way of learning is new, but it's growingly important, okay? So you see that in college you are adapting to different subjects, different levels of competitiveness, different classroom settings, and etc. Okay, so this is trying to challenge you, all right? And so that you get better. Using different forms to learn. But with that said, okay, you see that Polly will not be a responsible teacher if I do not challenge you to learn all these new forms. Okay. But in the meantime, Polly would not be effective teaching these new way of learning, okay, if I'm frustrating you too much. Okay, so you get to select 3 out of 4 exams to count towards the semester grade. So each of the 3 will be counting this much, okay, for the semester essentially. Okay, 4 over 3 multiply 10%. Okay. If you did very well already, hey, keep this, okay, and you can allocate less time for the subsequent exams. But if you have accidents here and there, it's also okay. Yeah, it's fine to fail, okay, in college, but don't fail the course, please. Okay, it should be hard to fail this course. Okay, all right. So learn to enjoy and adapt. Okay, and by the way, I think one of the students came with pads. Okay, that actually works even though you need to do PAs. Okay. Go on to the PA servers. You can just download mobile SSH or Terminus. Okay, so these are actually iPhone and pad apps that allow you to do SSH from a pad to the server. Okay, so those are the important announcements. Then let's go back to the lecture. So we actually ended the lecture here. Well, slightly after this, okay, we actually talk about message formats, particularly the request message in HTTP. But there were many questions at the end of the lecture on Tuesday, asking about this. Oops, let me go here. Yeah, there we go. Asking about this. We talk about HTTP runs in 2 different connection modes. One is what? Non-persistent connection. The other, persistent connection. So what I'm drawing here on the whiteboard, okay, sorry guys, over YouTube, you don't see this very well. So on the left, you see client talking to server. Okay. First round trip is for TCP to establish. First round trip is for the client and server to establish the TCP connection, right? And second round trip is then to get the base object, the base HTML. So if we are running in the non-persistent connection mode, for each of the reference objects subsequently, we need to do one round trip for TCP again, one round trip to get the first reference object. And there are 5 of them, so you repeat that 5 times. So 10 round trip times plus the 2 round trip times to get the base object. So altogether, 12 round trip times is required. Now, what about persistent connection HTTP? Well, we still need the first round trip time to establish what about persistent HTTP connection? We still need the first round trip time to establish TCP connection, and then we still need the round trip time to fetch the base object. Once the base object download is complete, we see all the reference objects in the page, right, in the base HTML, and then we can start downloading them. What does persistent HTTP connection suggest we do? Anyone? What do we do there? Okay, let's see. Oh wait, okay, so let me just give me a second. So I want to make sure this is working. I can see remote students coming. Oh, okay. Yeah, good. Good. Very good, except that okay, my OBS setting needs to be redone. Okay. Let me see if I can quickly fix this. Let's see. One more time. Can I read all this? There we go. Finally. All right. So yeah, so I can see the remote students' comments now. Yeah. What about persistent connection? What do you say? One more round trip? One more round trip? Do you agree? Very good. Why?
The data is transferred as packets, so you can.
Right. We can send 5 object requests back to back. So here, okay, starting from here, 5 requests back to back. And then 5 of these come back to back. Okay. Of course, 5 objects transmission time will be a little bit longer, so it will be 1 round trip time and a little bit more transmission time. So you see, 1, 2, 3 round trip time because there are 2 being the base object. And just 1 round trip time reference objects together. Right? Now, what about non-persistent HTTP with parallel connection? Okay, so this one here in the middle. So we just talked about non-persistent and persistent. What about this guy in the middle? What do you think? What about non-persistent connection with parallel? Oh, non-persistent mode with parallel connections. Well, non-persistent means, hey, after we get the base HTML, we close the connection. So for all these other objects we are asking for, we need to establish the TCP connection again. And for each of these objects, then we can actually start 5 connections in parallel. So I'll have to use the blackboard here. So meaning there's another connection here tries to establish TCP. Okay, on the same timeline, 5 more TCP connections need to be established, and then get the object. Reference object number 1, and this is reference object number 2. Alright, and number 3, number 4, number 5. But it all happening 2 round trip times. So together, 2 round trip time for the base object, and 2 round trip time for all the 5 other objects, reference objects. So altogether, 4 RTT. So 12. The persistent connection is slightly better, 3 RTT, and the parallel connection version, 4 RTT. Time is much shorter, but the amount of resource required, okay, to run 5 parallel connections is much higher. All right, so let's move on, given that this is kind of important. And so we ended up here yesterday, or actually 2 days ago. So we talked about the general format of HTTP requests. So in the end, I said that, hey, 3 parts in general, but not many of the HTTP requests send messages in 3 parts. Most of the time, just 2 parts. Okay, if we go back to the example, here. This is an example that does web object download, and it's downloading this page. So this get here means getting the page. For this particular method, or this particular comment, there are only 2 parts, right? Request, headline, and then the header line, comment line, header lines, and then empty. There's no body here. So this get method will generate an HTTP request message that contains only these 2 parts. Now, let me go back again. So get is not the only method. There's also post and head. So post there works this way. This is something that we do a lot already. You might go to some web pages where you need to fill out things like Google form. Or if you do Google search, right? There's a bar in the middle of the page, and you type in the keywords, so then it begins searching. So that is a form. So the upload of your message there in the search bar will go in a HTTP request message where the method in the request line is going to be post. Okay, so Input is uploaded to the server. And there in that message, you will see there's a body component. Okay, if we go back just a little bit. So that search keywords is going to be here. All right, so when you do exams on Google Form, your student ID name was going to go here. Okay, email address. So that was the post method. Now, for Google Form, where you fill lots of information, this is very much the method being used. But for Google search, because the keyword, probably just one or two, okay? For that kind of form, nowadays it's more common to just do URL get. Okay, so contain the search keywords in the URL like this. So this is www.google.com. Okay, and this is Google search, okay, and then keywords, something and something, or just one keyword. So we embed these words we want to upload or information we want to upload to the server, okay, in the URL contained in the request line. It's a little bit odd, but it's becoming more popular doing it this way. All right, so now you heard. Okay, there is get method, there is post method. In the older version of HTTP, there's one more method called head. What this head HTTP request message does is to ask the server, okay, for an object, okay, but the response coming from the server will leave the object out. So meaning header lines will be just like the regular response, but not the actual data. Can you imagine why? This is also growingly popular. Okay? For example, if we want to maintain cache, okay? When we download a page, a lot of times there's a cache space on your hard disk. Okay? Many of the browser will ask you, right, whether you want to cache. If you say yes, you cache these web pages you've been to. All right, and if you want to go to the same page again, what you do is this. You might be sending a head message telling what is the last time you get the page to the server. And if server sees that that page has not yet changed at all, it's actually going to send back just the header lines without the content because you have already the content. Okay. Sometimes it's just for the client to check the status of the server. Sometimes hackers use this to find out the status of the server. Is it Apache server? Does it support PHP? Things like that. Newer version, 1.1, support these three methods, but also these two. Put, this is to upload the file. Get is to download the file. Put is upload the file. And delete, hey, literally, delete the file. Now, if you consider these three functions, get, put, and delete, this is pretty much FTP. Starting from this point, once 1.1 is out, FTP, nobody is using it anymore. Okay, we are still using it, okay, but that's for the purpose of putting the web page, course web page there in a public way. All right, so that takes us to the response message. And that part is going to be a video. So let's go there.
Messages defined in the HTTP protocol.
Oh, sorry.
You see here, general.
Can you go back? Sorry. I've played it already a little bit.
Now, finally, the HTTP response message. Okay, the second type of messages in.
Oops, sorry.
In the HTTP protocol. You see here, generally, three parts. First, the status line. Second, the header lines. And the third, the data. So entity body, so to speak, from here and down. Okay, and these are very similar to the header lines we see in request message. Each line, you see attribute and the value. Attribute and status line. 1, 2, 3. Again, 3 components. Let's go through each one of them as well in a bit more detail. In status line, first here, yeah, familiar. So the version of HTTP the server is implementing is the first component in the status line. Second, this is the status code. So in HTTP, it defines quite a number of these status codes. Each of these indicate a different condition. Some more related to the server, some more related to the object being requested. And for each of these status code, there's a status word being shown as well. That's the third component in the status line. So 200 here indicates OK, meaning the HTTP server is working well and the object you're looking for has been found. And it's going to come here in the body entity. Now, second part, the header lines, we see date. Yep, this is the date, time, the request is being filled, and this response is being generated. The server, this is an Apache server, version 2.0.52. Yep, Apache is one of the most commonly used web server implementation. Yeah, I think you heard about the other one, Nginx. The Nginx is certainly rising. Okay, it's not quite yet the most popular one. Well, let me clarify. By popularity, I meant the number of machines running a specific version of web servers. So Apache is still the most used web server. But if you count only the number of downloads recently, it might be Nginx. That's why you see I said that it's actually rising. So I think maybe in just a couple months, there will be more Nginx server than Apache servers. Last modifier, yeah, so this is to indicate when is the object you're downloading last modified. Oh, okay, it's a really long time ago. All right, e-tag, what is this? This is actually, hey, for each version of the object that you are downloading, there comes also with a version number. So e-tag there is to indicate the version number. Nowadays, as you see, the HTTP protocol is not used only for downloading purpose. It can also be used for uploading. If there are multiple users there using different web browsers trying to upload the file, for example, poly and Caleb, the TA, tries to upload and override the grades Excel file, then you might have a consistency problem there. So the number here is to break time, to make sure that a newer version does not override the older version or something like that, to resolve conflicts, so to speak. And accept range. Yeah, yep. So, you know what? Earlier when I mentioned the head comment in the HTTP request message, right? So when you send such a comment in the HTTP request message, the server responds with only the status line with the header lines, but without the data. Okay? So server there can actually tell the client, you know what, I'm a server that allows you to request content in terms of bytes. So the client there seeing this can then send the request more officially, instead of using the head command, using the real get command, and request to download byte 0 to maybe 1023 or byte 0 to byte 100. Okay, So you could do a range request in a way. And the server's next header line, content length. This is to indicate the size of the file or the size of the object that you're downloading. So you see the file size of the object is one critical parameter. Okay? If you're implementing a web server, you need to know a way to find out what the file size is or the object size is. Okay, the size is a bit messy. Let me clear the markups. Keep alive. Oh, good. This web server implements persistent connection. Okay, and so it indicates timeout interval is 10 and maximum 10 requests. So this is a persistent connection, but in the connection, it only accepts up to 100 requests. All right, so if it's more than 100, then you will force close. The server will force close the connection. So connection, keep alive. Content type, yeah, just like the client size header line we see. Yeah, the client accepts content of a certain format. Here, okay, this is to indicate the object the client is asking for, which format it is. And we see this is text-based HTML file, and it's coded in ISO ep9. Right? And empty line, indicating this is the end of the header lines. Right after the empty line, the data goes here. If it's an HTML file, then hey, text starting from here. Okay, the first file. So this is an example of HTTP response message. You see the structure is very much like the HTTP request messages. Next is just to share a bit more. HTTP response messages status code. We've seen earlier in the example, 200 OK. This is saying request is successful, object is already embedded. 301, that means the server is saying the object is moved to a new location specified later in this message. So sometimes when you run into a message like this, you see, oh, click here. That's going to take you somewhere else. It's a redirecting link. If you see status code 400, that means your HTTP request format is not quite correct. Bad request. 404, that means the object you are asking for is not found. 505, HTTP version not supported. So in case you're using a very, very, very old browser, or if you are contacting a server that's very, very old, and yet your browser is implementing something newer, then you might not be able to communicate. The server is going to tell you this. Sorry, 505. Good. And now we're ready to look at an example of what HTTP requests and response might look like in real life and in action. So what I will show you in the demo coming next is to do this. Telnet to the favorite web server here, and we're going to use this machine here that the textbook author has set up for us. So we'll telnet to gaia.cs.umass.edu at port 80. Okay, what it does is to open the TCP connection to port 80 where there's a server already running, a web server already running. And anything typed in will be sent to port 80 at this guy. So Telnet is a remote logging application, just like SSH or RSH, if you know what it is. It's another remote logging command for native Unix users. All right, so Telnet is very, very old. Many operating systems probably doesn't support it anymore. But I've already installed it on my Mac, so we're going to show that in a little bit. Now, once we telnet to the web server, and we'll type up some things. Let's try typing this. Get path name and file name as the argument for the get command, and then the version of the web browser. So we'll be pretending that the telnet here is a HTTP 1.1 client. And host gaia.cs.umass.edu. Right? So header line. So essentially we are trying to do a human web browser, okay, by typing online right here an HTTP request message. So once we are done with this, we hit return, okay, and then we hit return again. Needs to have a what? A \r\n here in order to complete the HTTP request. All right, so the whole thing is going to be like this. And yeah, we'll see what pops up in return, what the server there at umass.edu sends back. Okay, let's not sniff the traffic. Let's just look at the response coming out of the telnet program. All right, so let's switch to the demo mode. All right, let's telnet to gaia.cs.umass.edu at port 80. All right, connect it to gaia.cs.umass.edu. Now let's pretend to be a web browser. Get. Oh, wow, that's pretty long. The pattern file, pretty long. Let's copy it from the sites. Over here in print. All right. And then host poly.ntu.edu. How about that? All right. And one more empty line to indicate this is the end of the header lines. There we go. Wow, it's returning a lot of things. Scroll back, and scroll back. Wow, very long in fact. But it looks like it's an HTML file, right? It's an HTML file. Now, this is a hyperlink to an text HTML file. Okay, let me scroll a bit faster. I don't know how long this is. Oh, there we are. Yeah, so we typed up this line here. Okay, and we also say we are host poly.ntu.edu.tw, and an empty line, and then return again. The whole message gets out to the web server at gaia.cs.umass.edu, and the web server returns this http://1 to the 200. Okay, and header lines number 1, the date. Header line number 2, the server. Oh, it's an Apache server. X powered by PHP. See? Content length, content types. And hey, empty line to indicate this is the end of the header lines. And starting from here, the real body. So we get the output of calling this PHP query at this path. Let's see, interactive problems, computer networking, a top-down approach. Oh, okay. So this looks like the main page of all these interactive exercises that we see every now and then on the slides. All right. So there, essentially very text-based interaction between the client and the server. As human beings, we could also do it right here, right now, online as a web browser. All right. And I think let me just go back a little bit here. You see here, 200 is a very classic example of, hey, the syntax defined in a application layer protocol. In HTTP, to be exact, 200 is to indicate OK. So OK here is just to say it explicitly, the semantic of 200. Right? So that concludes the messages format, semantics, and syntax of HTTP.
And we move on to the, guess what? To the quiz. Oops, sorry, here. And let's go to the quiz, which is all the way down. So similar to the quiz 7, right? So quiz 7 is asking about the request message. This one is asking you using a reply message as an example. So first part of the quiz is asking you, was the request successful? Second part, how many bytes are there, okay, in this object? And what are the first 5 characters in the doc being returned? Okay. This is to blow it up a little bit bigger. Okay, was the document found successfully? Yes? 200, okay, right? Q2, how many bytes are there? 3A74? That's probably the, yeah, the content length, isn't it? And what are the first 5 characters? It's what? The greater than or less than? Exclaimer sign, right? And the DOC. Okay, so 5 characters at the beginning of the document that we're retrieving. Good. Mm. 200, okay, yeah. All right. Very good. Great. Good. So that takes us back to the lecture. And so we're done with the message format. Okay, request and reply should be very clear. Now we go on to another subject called the cookies. And it's going to be a video. So let's go to the video. Let's kill this one. And this is the remaining one. Okay, I see the answers are flying in. Very good. Switch to screen, and then let's play.
Next, cookies. Yeah. Many websites these days will try to prompt you to set up cookies before they allow you to visit the website further. So it's very, very relevant to our everyday life. Let's see how it works. Okay. First thing is, the cookie setup process is always initiated from the website. So meaning from the web server that your web browser is requesting objects from. So web server there is going to send a message to the web browser carrying a special header line. Okay, it's the cookie setup special line. And the web browser there, upon receiving such a message, it's going to generate, okay, a corresponding message if you click OK to insert cookie. And that message is going to carry again a special header line saying cookie OK. All right, so exchange of messages between cookie setter and cookie allower. Now, when you say, OK, I will allow setting of the cookie, your browser is going to add an entry to the special cookie file on your local disk. Okay. So that is exactly what's expressed here in the special cookie setup line. And when the server receives the message allowing cookies, server would then add a special entry as well to the backend database. And that entry set up here and here will actually map to each other, allowing the server to identify who you are and when have you visited the website last time. Let's use an example to explain. It will work slightly better. Let's say Susan always accesses internet from her PC. And she's visiting a specific e-commerce site the first time. In the initial HTTP request, okay, that arriving at the server, the site will then create a unique ID, okay, and that will be an entry being added to the backend database. Right? So that ID is going to be carried. Okay, in the message, the site sends back to Susan. So that's going to be set cookie and then the number created here. All right. So local hard disk you have there, or Susan has there, will have that entry, okay, set up in the cookie file. So this will go back to the server, okay, carrying also that special ID that Susan has already allowed to set up. And then at this point in time, the server would finally enter the entry to the backend database. So that's the way it works. Let me illustrate, okay, and so that you know clearly what's going on. Client, server, or Susan, Amazon.com. Now, at the client side, you have this special cookie file, and it's managed by the web browser. And you might have clicked OK to eBay. So eBay has already set up a cookie entry carrying unique ID A734. Server here has a local disk as well. It's maintained more as a backend database instead of just a simple file. So, but when you visit the website Amazon.com the first time, you send an HTTP request message. Now, of course, you have not yet been in Amazon before, so there's no entry for the Amazon website. Okay, so in your initial HTTP request message, there's not going to be any cookie special header lines. All right. So when Amazon.com here receives HTTP request, of course, it will try to grab the objects that you're looking for and try to generate the HTTP response with it. But in the meantime, it will be creating an ID, okay, for this particular user, okay, and add that to the database. And in the response, it carries the web object that you're looking for, but it also carries the special header line, the set cookie line. Okay. And hey, see the ID created is carried over through the HTTP response message back to the user. So, web browser here sets up one extra entry saying, hey, for Amazon the website, use ID 1678. So for the subsequent visit, subsequent browsing, all the HTTP request messages is going to carry the cookie OK, and I am user 167A header line, right? So here the server, of course, will be generating the web objects, generating the HTTP response message that you're requesting with the request message. So response message. But the response message might also contain additional content, okay? Server there could be seeing your browsing history a couple clicks back and discover that, hey, you might be looking for a specific item, okay? And then recommend potentially items you'll be interested, okay? So that might also be part of the response messages. So showing the items you are looking into buying as well as related products.
All right, so we end here. So we'll resume cookie next Tuesday. Okay, guys. Okay, guys, so I'm just gonna end the stream. Okay, bye, Yuanxiang.